Okay, so today is the last video for Unit 1. This is Unit 1, Day 8, and we're solving absolute value inequalities. So it's very similar to what we did yesterday, except that was equations. Here we've got inequalities. And just like yesterday, the first step is going to be to isolate the absolute value first. So you want to get the absolute value part as the only thing on the left side of the equation. But in this case, it's an inequality now, not an equation. Now you have to decide, is it going to be an and or an or? So for example, the first problem, the absolute value is the only thing on the left side of the inequality. So once that step is done, look at your inequality. It's less than. So less than starts with an L. The word lago, L-A-G-O. So less than tells me that this is going to be an and graph. We won't really use this until we get down to the graphing part, but it's helpful to write it now so that when you do graph, you'll know whether you shade in between the two numbers or on the outside of the two numbers. All right, so step 3 is to split it into two inequalities. So you got x minus 3 and x minus 3. That doesn't change. This is going to be less than 4. The thing that you need to know about today is that when you make it negative 4, this is going to switch. So when you split into two inequalities, make sure that you flip the second one. So it was less than, that becomes greater than. Now you're just going to solve like you normally would. So I'm going to add 3 to both sides. I get x is less than 7. Here I add 3 to both sides, and I get x is greater than negative 1. Now this is an and. So remember, you could leave your answer like that, or you can write it with the three-sided inequality, where you have negative 1 is less than x, which is less than 7. Then we're going to find on our number line where's negative 1, where's positive 7, decide if it's open or closed circles, and then if it's and, you're going to shade in between. And these are open circles because it's just less than and just greater than, not equal to. All right, so we're going to do number 2, same way. Is the absolute value isolated? Yeah, it's the only thing on the left side of the inequality. So now we're going to look at lago. It's greater than this time, so that tells me this is an or. Now I'm going to split into two inequalities. 2x minus 1 on both sides. It's going to be greater than or equal to 5. This time it's going to be less than or equal to negative 5. And then just solve like you normally would. So add 1. 2x is greater than or equal to 6. Divide by 2, and I get x is greater than or equal to 3. Over here, I'm going to add 1. 2x is less than or equal to negative 4. Divide by 2, I get x is less than or equal to negative 2. This one is an or, so I don't need to write it as a three-sided inequality. I just need to find negative 2 and positive 3. These are both filled in circles, and it's less than negative 2, but greater than or equal to 3. So you shade on the outside. All right, problem number 3, I do need to isolate because this absolute value is not the only thing on the left side. So I'm going to add 1. Absolute value of 6 minus 2x is greater than 2. All right, now I'm going to look at lago. So this tells me it's greater than, which is an or. Okay, so now I have 6 minus 2x is greater than 2. 6 minus 2x is less than negative 2. And then I'm just going to solve each one separately. So if I subtract 6, I get negative 2x is greater than negative 4. If I divide by negative 2, I get x is less than positive 2. Notice that I had to flip my sign. Here, I have negative 2x is less than negative 8. If I divide by negative 2, I get x is greater than 4. And this is an or. So I've got that. All right, now you want to find where is 2, where is 4, and we're going to shade on the outside. All right, problem number 4. Absolute value is already isolated. So I can look at lago. This is less than, so that tells me it's going to be an and. 2x minus 3 is less than 7. 2x minus 3 is greater than negative 7. So I'm going to add 3. 2x is less than 10. Divide by 2, x is less than 5. And I'm going to get my other answer. 2x is greater than negative 4. When I divide by 2, I get x is greater than negative 2. Now remember, because it's and, I can say that x is in between negative 2 and positive 5. All right, so last step is find the numbers on the number line and graph. So you're going to graph in between negative 2 and positive 5, and they're both open circles. All right, on the back side, we're going to do just the odds, and then you guys are going to try the even ones on your own, just like we did yesterday. All right, so number 5. The 5 we need to get rid of. So we have absolute value of 4 minus 3x is less than or equal to 2. Then I'm going to, I forgot to do logo. So this is less than, that's an and. Now I'm going to do 4 minus 3x is less than or equal to 2. 4 minus 3x is greater than or equal to negative 2. And then you're going to minus 4 on both sides. Negative 3x is less than or equal to negative 2. When I divide by negative 3, make sure that you flip your sign. So you have x is greater than or equal to 2/3. Here I'm going to have negative 3x is greater than or equal to negative 6. When I divide by negative 3, I'm also going to flip my sign. So I've got x is greater than or equal to 2/3, and it's also less than 2, which you could write as a compound inequality. So 2/3 is less than or equal to x, which is less than or equal to 2. All right, so 2/3 is about here, 2 is about here, like 1 would be right there. So we want to go in between 2/3 and 2. All right, we're going to go to number 7. So absolute value is not isolated, so you need to undo the 4 and the negative 6. You want to undo a minus first by adding. So 4 times the absolute value of 5x plus 3 is greater than or equal to 12. This is being multiplied, so to undo multiplication, we divide. Absolute value of 5x plus 3 is greater than or equal to 3. Then you're going to look at what's your symbol. So it says greater than. That tells me logo, greater than is or, And so now you're going to split it up into two separate inequalities. 5x plus 3 is greater than or equal to 3. 5x plus 3 is less than or equal to negative 3. All right, so we're going to subtract 3. We get 5x is greater than or equal to 0. When I divide by 5, I still get 0. And then over here, I'm going to subtract 3. 5x is less than or equal to negative 6. And I divide by 5, x is less than or equal to negative 6/5. And this is an or. So 0 is here. Negative 6/5 is a little bit less than negative 1. You could just label this as negative 6/5. So I want numbers that are less than negative 6/5 or greater than or equal to 0. All right, last one we're going to do together is problem number 9. So the absolute value is not isolated. All right, I've got the plus 4 to undo. So we have absolute value of 5 minus x is greater than or equal to 6. Before I split it up, I'm going to say greater than is or. So 5 minus x is greater than or equal to 6. 5 minus x is less than or equal to negative 6. And then I'm going to subtract 5, divide by negative 1. So x is less than or equal to negative 1. Over here, I do negative x is less than or equal to negative 11. When I divide by negative 1, I get x is greater than or equal to 11. And this is an or. So I just need to find negative 1 on my number line and positive 11. These are both filled in because they're or equal to. And I want to shade on the outside. All right, so now what I want you to do is do 6, 8, and 10 on your own. You're going to pause the video, and then I will show you the answers. All right, so problem number 6. Here's the answer to that. Okay, you could double check your solutions. All right, and then you're going to try 8 and 10 on your own. And then I'll show you the answers to 8 and 10. Okay, so you can go ahead and double check your solutions. And then don't forget your secret word of the day. right, the word is going to be highlighter.